All right, continuing on with forces. Get a share screen going. So forces, as I mentioned, come in two different varieties, linear force and angular torque. And these can either be in the global Cartesian coordinate system or in the coordinate system of our object. Forces are applied every fixed update. I don't think that should be every frame. It's every fixed update. And so we can kind of manufacture our own gravity with this kind of object. I have a sphere here with a rigid body, and I've added a constant force component to it. So here's my sphere. Here's my constant force component, and you notice it has two forces, one absolute relative to the world coordinates and another relative force relative to the local coordinates. And I have the same for torque. Torque is a force around an axis, whereas force is in a direction. So if I play this just as it is, the ball falls and bounces on the ground, and that's all there is to it. But with a mass of 1 and a gravity acceleration of minus 9.81 and my F equals ma, if I make this 9.81, I should be applying a force that exactly will balance gravity. And so now here with my little object, it doesn't fall. In fact, it stays kind of stationary. I can still push it around and get it going, and it's going to take off and go wherever it wants to go. And I haven't turned off gravity. Gravity is still on. It's just I'm balancing exactly it with my own force. Of course, that's not terribly interesting. Let me get over here where I can see the axes. So the way my ball is oriented, I have the red or X axis pointed out to the right here. I have my Y or up pointed up. And if I look at it, I can see that I have the forward vector pointed that way. So if I apply a force, let's say in the negative X direction, and these are global and local are right now the same. The way this thing's set up, the global and local coordinate systems are the same. So let me apply a negative force here in the minus X direction, which means this thing should take off that way. Now this is not just an absolute movement. This is a force exerted in that direction. And so as it takes off, it's going to encounter obstacles, some of which it may get over. It did in that case. So that's absolute force. And we can, of course, force it any direction. Now, relative force is a little different. Let me apply a relative force in the Y direction. So I'll push this. This is going to push the object up. So let me make this a force of 9. So that's going to be a little less than gravity. And it's going to push it up. Well, it's going to fall down slowly. That didn't work. Let me change my orientation a little bit here so that something else happens. So the 9 now is going to be relative to the object's axes, the local coordinate. So that's going to push it in this direction. Now, as it bounces and it rolls, that y-axis is changing direction all the time, and it's taking off in different ways. Let me make this 10 and see what happens here. No, it's not taking off. Let me make this 10. So applying a force on a local axis is going to make this thing kind of behave erratically as it is forced in constantly different directions all the time. A torque is going to make a rotation. So if I give it a torque about the y-axis, and let me reset that back to vertical here. This is going to make it spin about its y-axis. And so it's an accelerating torque that's going to make it spin faster and faster. There is a limit to how fast things will spin. That's one of the physics settings, but that's clearly not going anywhere. It's just spinning about its y-axis. If I make that about its x-axis, about the world's x-axis, this is now going to make it spin around the red arrow, and I assume the thing will take off and head off that way. It's about the global axis, not about the local axis. Now, similar to what happened when we did relative force, if I do relative torque, again, about the x-axis, and this is now about its local x-axis, which changes periodically. You see completely different behavior. So that's the constant force module, and I'm going to stop it there, and I will pick up next time with colliders. We're going to talk about the different colliders in detail. Stop sharing, and I'll end recording, and I'll see you in class. Bye.